Good morning, students. Short lesson today. Today we're taking a look at constellations. You'll notice when you access the student copy of the note, that is the Word document with the blanks, that there is some homework there. I don't have it on the PowerPoint presentation. The PowerPoint presentation is only about 6 slides, but it is section 7.2 in the textbook, and there are homework questions that go with that. I think they're on page 286. So please make sure that you, just because I don't mention them in this video, or you don't see them in this video, please check the student copy, because that information will be in the student copy of the note, and that you can complete those homework questions. Okay, so let's get started. Okay, we're taking a look at constellations. So it's section 7.2, constellations. Let's put this in slideshow mode. Okay, so we look up at the sky, we see patterns. So I told you in the last lesson that the earliest astronomers, before we even had telescopes, or even really the kind of technology we associate with astronomy today, astronomers were following patterns. They were looking at patterns in the night sky. Now, before we talk about those patterns, we have to talk about what a star is. We have a star in our solar system. We call it the sun, but there are lots of stars out there. We talked about that in the last lesson. Okay, so what is a star? What it is a massive collection of gases that emits large amounts of energy. It glows. Okay, stars emit their own light. We call them luminous because they emit their own light. Okay, now what we do is we look at those stars, and we don't recognize patterns, but in our mind we create patterns with the way those stars are arranged. Okay, and we call those patterns constellations. Okay, and it's groups of stars that seem to form a distinctive pattern in the night sky. So for example, this middle constellation here is Orion. That's Orion's belt. Okay, and you can see how they've shaded in this drawing of Orion, who's a Greek warrior going into battle, or you know, some kind of battle going on there. Okay, but this doesn't exist. There is no picture of a guy holding a sword in space. What exists in space is what's in yellow, the stars. The lines that connect them don't exist, just the dots, the stars. Okay, and these stars, they're always in the same place in the night sky. Okay, we can see them, and what we do, what early astronomers did, what we still kind of do, is we imagine that they form a pattern. And that's actually really, you know, it doesn't necessarily mean anything that it's Orion as a warrior, but because we can form a pattern in our minds, we can say, oh, well, all those stars, they go together, they're near each other, and so that's a location in space. Okay, and again, if we look here, this is the picture of a scale, right? We call this the constellation Libra. Okay, well, it doesn't really look like a scale. It's just a whole bunch of stars, and we've constructed a pattern around it. But again, that helps us with saying, oh, well, that's that location in space. Those stars are always located around each other. Okay, and so before we even knew what stars were, before we understood the magnitude of space, how big space was, where these stars were, what they were made out of, we were able to say, hey, look, those stars, they're always in the same place in the night sky. We'll imagine a shape around them, and we'll give it a name. Okay, and that's important because it helps us to navigate, or it helped us to navigate, okay, in the days before we had GPS, right, which is most of our recorded history. Okay, and it helps us to categorize the sky now, the night sky and space. We can direct ourselves in space because we're able to group together these stars in imaginary shapes. No, the shapes don't really exist, but we imagine them to be there. We can say, hey, that's a pattern. Now I know which way in space I'm looking. It also helps us to tell the seasons. I'll get to that a little bit later. Okay. So when we look out in space, we see those stars. It looks like they're close to each other. Okay, but that's not true. They're actually light years apart. Okay, now what is a light year? That's the distance that light travels in 1 year. Okay, so at a speed, so light travels at a speed of 300,000 kilometers per second. That's very fast. Okay, 300,000 kilometers per second. Okay. light travels about 9.5 times 10 to the 12 kilometers in 1 year. That's a very, very far distance. It's extremely far, okay? So what does that mean? Well, let's look at this picture. This picture is of the constellation Cassiopeia. And if we look here in this flat plane, we're going to see what it looks like from Earth. It looks like this W shape from Earth. But in reality, the stars that make up that shape are all many light years apart. The closest one, well, looks, I mean, there's 200 light years. So the closest one looks like it might be, 50 to 100 light years away from us. Okay, and the furthest one looks almost 800 light years away from us. So that's a big distance. These stars are very far apart. Okay, they're extremely far apart. But when we look at them from our perspective, okay, they look like they're right next to each other, and it sort of allows us to say, okay, it's that direction in space. That's the direction that we're heading in. It allows us to orient ourselves in space, to say, oh, those stars, they look like they're forming the shape Cassiopeia, and so I know which direction we're looking in. Okay, even though they're not actually close together, even though they're not actually designed by anyone to show that shape, we just invent that shape to help us get our bearings in space. Okay. When we look at a star map, okay, it shows constellations and individual stars. Star maps can also represent stars by dots of varying size. The larger the dot, the brighter the star. Okay? And astronomers use the term apparent magnitude to describe how bright a star is. Okay? So apparent magnitude is the brightness of a star seen from Earth. Okay? And it dates back to a Greek astronomer. And when I say Greek, I don't mean Greek today. I mean ancient Greece. Okay? Hipparchus. And what he did was he assigned the number 1 to the brightest star and the numbers 2 through 6 for fainter stars. Okay, and we can actually go beyond 6 because we can see stars that are further away, and we can go into the negative numbers because we can see stars that are even brighter. Okay, but what it means by apparent is it says that's the brightness. Okay, so it's the brightness. But brightness can be affected by 2 things. It could be how much light the star is emitting, but it could also be how close or how far the star is. So consider this. A very, very bright star that's very, very far away might seem faint to us, and a not so bright star, or a star that's a little less bright, that's a little closer, would appear brighter to us. And that's why we call it apparent, because it's not exact. It's just the way it looks to us. Okay? So just because a star appears brighter doesn't mean it's closer or doesn't mean it's bigger. It's just the way it appears to us. Okay? So when we look here at this star map, we can see that the brighter stars are a little bit bigger and the less bright stars are a little bit smaller, but it tells us nothing about the actual star. We actually don't know how far away or how close the star is. We don't know how big the star is. We don't know how bright the star actually is. We only know how it appears to us. Okay, and that's the tricky thing about looking at stars, is because they're such enormous distances away, it's hard for us to tell just by looking at them, just by eye, how bright they actually are. We can only see how bright they appear to us. Okay? Right? Because if I have the exact same light bulb and I hold one light bulb here and then I give the second light bulb to someone across the street, the one that's close to my face is going to appear brighter, but of course it's the same light bulb, right? It's just that it appears brighter because it's closer. Okay? So it's a sort of thing that can kind of play a trick on us. But it is useful at the same time for categorizing, right? So it might not be exactly accurate. It might not be saying, yes, oh no, Capella appears brighter to us, so it must be a bigger star. No, that's not the case. It's brighter doesn't mean it's bigger. It's brighter doesn't mean it's closer. We don't know. We don't know. It's hard to tell. But it at least helps us to identify that that's Capella, and that's the way it looks from here on planet Earth. Okay, it looks to have that apparent magnitude from planet Earth. And so now we can say, okay, that's Capella in the sky, or that's Polaris in the sky, because it has the appropriate apparent magnitude. Doesn't tell us anything that's actually true about the star, but the information of what it sort of looks like to us, the apparent look, helps us to orient ourselves and say, okay, that's Polaris because that's the way it looks from our perspective. Okay. Now, the last thing I want to point out in this diagram is look at the bottom corner. It says late spring. Okay. We should know by now that the seasons are change as we revolve around the sun. Okay, so during certain seasons, so if this mug is the sun, okay, this is what my mug is the sun, okay, on this side, maybe it's winter, okay, and half a year later, as we revolve around the sun, we end up over here and it's summer, okay. So we're actually in a different location in space at different times of the year. And that means, you know, if we're over here in winter and we look up at the night sky, which should be in that direction, okay, we look at the night sky in that direction, we'll see certain stars and therefore certain constellations. Once we've revolved all the way around the sun, we look this way, we will see different stars. And so the stars that we see, right, in the night sky, give us some indication of what season it is. Okay, so here it says when we look up at the sky in late spring, these are the stars that we see. In the summer, we'll see slightly different stars. In the fall, in autumn, we'll see different stars in the sky when we look up. And of course, you know, this one's going to bake your noodle. If you're in the northern hemisphere, you will see different stars in the sky than people who are living in the southern hemisphere, okay? Because they're looking in a different direction at the night sky, okay? And that, again, helps us to orient ourselves. Certain stars will appear in certain places in the night sky, okay, depending on your location on the planet and the season that you're in, okay? Now, of course, to us, it appears as though the stars are moving, but in fact, it's the stars are more or less staying in place, and it's the planet Earth that's revolving around the sun. That's appears the stars are moving, but in fact, we're moving. Okay. Okay. Constellations and asterisms. Okay. Now, there is an organization. It's called the International Astronomical Union, and it names and classifies celestial objects. Okay, and it lists 88 official constellations. Some examples include Cancer, Cassiopeia, and Ursa Minor. There are lots. There are 88. Okay, and you've heard some of these before. Smaller groups of stars that form patterns within a constellation are called asterisms. Okay, an asterism could be like the Big Dipper, which is a small piece of a larger constellation called Ursa Major. I'll show you on the next slide. Now, what I'm going to say here is I've mentioned some words. Cancer is a word I've mentioned. And of course, if you read your astrology in the newspaper or on Instagram or Twitter, then you'll say, oh yeah, that's my sign because I was born in such and such a month. I'm a Cancer, or I'm an Aries, or I'm a Libra, or I'm a Sagittarius, or whatever. That's not real science. Okay? That's astrology is not science. My girlfriend will always say to me, well, I'm just like that because I'm a Libra. No, that has nothing to do with it. You're like that because you're in a miserable mood. That's why, okay? So what astrology does is it takes some information that scientists discovered, which is just that, hey, there are some stars in the sky and they kind of form patterns that can help us to orient ourselves. And what they've said is, no, if you were born at this time, then you're represented by this sign. And that means your personality is going to be such. That is pure BS. None of that is true. That's not real science, okay? So when I mention constellations like Cancer or Libra or Sagittarius, these are constellations, the real constellations, the real arrangements of stars that we use to orient ourselves in space. But they have no effect on your personality. Doesn't matter what month you were born in. It makes no difference what your sign is. All that is what we call pseudoscience. In other words, it sometimes sounds like science, but it isn't. Okay, so do not be confused by that. Okay, those constellations are real. Okay, we imagine patterns around them to help us orient ourselves, and that's it. They don't have an effect on your personality. All right. So look on the next slide here. You'll see a number of different constellations. So where is So here's Ursa Minor. Okay, Ursa Minor. Ursa actually means bear, and so with Ursa Minor, there's a small asterism, which is, I believe, this star here where my pointer is, and these 4 stars that we call the Little Dipper because it looks like a little spoon. Okay. And the same is true for Ursa Major. It has the same kind of shape. It looks like it's got a scoop and it forms a big bear, and or we imagine it to form a big bear. And then the scoop part is called the Big Dipper. Okay, I'm going to show you another one. This is a famous one. Let's see. This right here is the constellation Orion. So that's the constellation. These 3 stars here that my pointer is on is an asterism called Orion's Belt. Okay. Just helps us orient ourselves. Doesn't mean anything. Doesn't affect your life or your personality. All right. But that is about it for us for this lesson. So I think, short lesson, make sure you complete those homework questions. And until next time, make sure you're staying healthy and safe. Take care. Bye-bye.